In this video, we're going to do two examples of integration by substitution, and then I'm going to give you two to try on your own and then show you my solutions. Integration by substitution is used primarily for situations where we have products or we have quotients. And what we're looking for is that basically we have a piece of a function that could serve as our u, where the derivative of that function, du, is also in the problem. And I think the best way to look at this is through an example. So in this first example, if u were equal to x cubed, then du, and the real way to do this is to say du dx, the derivative of u with respect to x, is 3x squared. But then what we always do right away is we multiply the dx over. And what we can see here is that we don't have a 3x squared, but we have an x squared. And we could make these exactly the same, exact matches for a substitution by putting a 3 on the x squared. Obviously, we're not allowed to just multiply by 3, so we put a 1/3 out front to offset it, because 1/3 times 3 is 1. We haven't changed anything. But then we can replace our x cubed with a u, just like that, and this 3x squared dx can get completely replaced with just a du. So my integral becomes 1/3 the integral of the cosine of u du. Well, the antiderivative of cosine is very easy. It's just sine. And to finish the problem off, we just go back to what we began with, which was an x cubed in place of u, and there's our final answer. In the second example, we have an x in the numerator, and on the bottom we've got a 5x squared. So hopefully you can see, like, oh, if u is going to be the denominator, the derivative of that would be the numerator. This is going to help us deal with this quotient. Again, we're trying to eliminate quotients and products into simpler things we can integrate. So in this case, let's let u be 1 plus 5x squared, in which case du dx is 10x. Again, we just always right away multiply that dx over. So if I could make this 10x, that would be a perfect substitution. I'll offset that with a 1/10 out front. So this entire denominator is just going to become u, and this is just going to be a du. So my integral becomes 1/10 the integral of 1 over u du. The antiderivative of 1 over u is natural log. And oftentimes you'll see the natural log put inside an absolute value to kind of warn against any domain issues. We won't need it in this particular problem because what we substitute back in is always going to be positive, but it's not wrong to put it. There we go. All right, here are two for you to try on your own. Please pause the video. If this helps you, please like and subscribe. I have entire playlists of Calc AB and Calc BC, or Calc 1 and 2 help. All right, here's how I would solve these problems. I would begin with this by just rewriting this as a 1/2 power. And then I would make u 3 minus 4x squared. So du dx is negative 8x. I'm going to add the negative 8 here to make a perfect substitution, but then offset it with a negative 1/8 on front. So my integral is going to become negative 1/8 the integral of u to the 1/2 power. Everything else would be substituted out. I use power rule. I raised the power to 3/2 and then put a 2/3 out front. I still had that negative 1/8. Negative 1/8 times 2/3 is negative 2 over 24, or negative 1/12. And substitute back in for u. So plus c on the end. Okay, and this other example, I would let u be 2 minus x squared, and then du dx is negative 2x. Yeah. So I'd like to put a negative 2 there, and I can offset it with a negative 1/2. So this becomes negative 1/2 times the integral of 1 over u cubed, or u to the negative third. If I raise the power to negative 2, and then divide by that new power. And I already had a negative 1/2 out there. So negative 1/2 times negative 1/2 is positive 1/4. And then it's, 2 minus x squared to the negative second. But better to put that in the denominator if I can fit it. And I'm going to put a plus c down there. Again, if this helped you, please like and subscribe. I have a lot more examples and videos about substitution.